Hello and welcome dear learners to the NPTEL course on Nutritional Epidemiology, a way towards a healthy life. In the Module 2, the study design and epidemiological methods for the chapter 20, we will be taking the discussion on measures of association and effect. So, we will be talking about the risk, rate and odds, the relative risk, the odds ratio, the hazard ratio and the risk difference, attributable risk. We'll be also discussing about the population attributable fraction, that is PAF, and interpretation in the nutritional context. It will be taken for the discussion of association and effect. So if you talk about the measures of association, quantify the relationship between an exposure, might be an example we can take for dietary intake, nutritional levels, dietary patterns, and an outcome might be a disease, deficiency or mortality. So in nutritional epidemiology, this measure helps answer the questions such as, does high salt intake increase hypertension risk? Does fruit consumption reduce the cardiovascular disease? Or what is the proportion of diabetes that cases could prevent by dietary change? So these are the questions which are very important to measure. They are broadly classified into relative measures and absolute measures. In the relative measures, they compare the risk between the groups, versus in the absolute measures, they quantify the actual difference in the risk. So now we will understand the rate, ratio and proportion. For a rate is a measure of how often an event occurs in a population. So you can understand it is to see over a specified period of time, and it includes the element of time. So time is very important over here. So if you take the formula for rate, it is number of events divided by % time at risk. So you can say here it is very important to be stated as time to be taken as a component to divide it. For example, in a study, a nutrition program was implemented in a community of 2000 adults and they were followed for 1 year. During this period, 60 new cases of anemia were detected. So you can understand 2000 adults population, study was done for a year and 60 new cases of anemia were being seen. So the % time, that is 2000 into 1 year, that is 2000 persons years. Rate is 60 divided by 2000 is equal to 0.03 per person year. So you can understand the rate is being seen as 60 divided by 2000, that is 0.03 years. So what can be the key points to understand rate? It has a time as a very important component and it gives the speed at which the event occurs. So you can calculate it. And rate is commonly used in cohort studies and for rate events. You can understand the importance of time being used in cohort study for the rate. Okay, then comes with ratio. What is a ratio? A ratio is a comparison of one quantity to another quantity of the same kind. Okay, so and the formula is quantity A divided by quantity B. For example, in a study of 120 males and 80 females having a vitamin deficiency, you can understand what is a ratio. So male versus female, 120 male versus 80, so the ratio is 3:2. Okay. So what are the key points? If you are saying it is more like a comparison. So you can compare two quantities. What is the quantity over here? One is male, the other is female. The unit of measurement cancels out. So order is important. A is to B is different from B is to A. So the key points for ratio is comparison, which is very important to be highlighted over here. Then comes proportion. A proportion is a part of a whole, and it is a special type of ratio in which the denominator is the whole. So here the denominator is very important. For example, out of 500 children who were surveyed, 125 has anemia. Okay, so proportion will be 125 divided by 500. So the proportion will be 0.25 or 25%. So out of the 500, 25% of the children were having anemia. So it is being seen as a proportion where you can state that what has happened. So if you can take it, what it describes to state that the importance of proportion is, it describes as a part of a whole. So there is a part which is very important over here. It gives a range from 0 to 1, that is 0% to 100%. So if in the previous example you can see the percentage was coming, okay, from the whole range of the 500, and it does not include the element of time. There is no time where you can see over here. So time is not a component over here. Time is never being seen stated over here. So in proportion there is a part as a whole to be seen. In ratio there is a comparison of two quantities, and in rate actually there is a time as a component actually which is being seen, which is giving you a speed along with it. Okay. So here comes the discussion that we have taken for the rate, ratio and proportion. Now we will proceed with the other sets to understand more in detail for the next part, that is relative risk, odds ratio and hazard ratio, RR, OR and HR. So these are very important things. You have to pay attention to this to understand with the examples which I am trying to state over here. The relative risk. What is relative risk? The ratio of the risk of disease in the exposed group to the risk in the unexposed group. So this is again a ratio. In the previous section you understand what is ratio, so you have to apply what is a relative risk. So there is a ratio of the risk of disease in the exposed group to the risk in the unexposed group. So this is used in cohort studies, randomized trials where the incidence can be measured. So in the 2x2 table actually for the cohort study where you can find the exposed population and the unexposed population. So the total is, here it is A plus C, and when it is no, B plus D, that is for exposed no is B, and for unexposed the no is being stated as D. So for exposed it is A plus B and unexposed it is C plus D, and the total here is like C divided by C plus D. So if you have to talk about the formula for relative risk, it is risk in exposed divided by risk in unexposed. So it is equal to A divided by A plus B divided by C divided by C plus D. So if you can take the example over here, it will be very clear to you. Incidence of diabetes in high sugar intake group is equal to 20%, and incidence in lower sugar intake group is 10%. So what is the relative risk over here? 0.20 divided by 0.10, so that is 2.0. Okay, the interpretation is like exposed group has 2 times the risk of developing diabetes. So it is very stated clear that there is no association if you take it as RR is equal to 1. If it is higher, increased risk; if it is lower, it is a decreased risk. So the interpretation also comes very clear, and it is very stated that relative risk is exposed risk to the risk in the unexposed group. Okay. Now comes the odd ratio for discussion. Odds ratio is the ratio of odds of disease in the exposed group to the odds in the unexposed group. So here odds is very important over here. So used in case control studies, odds of the disease cannot be directly calculated at the risk. So it can be seen to state that when you take the formula for odds ratio, it is very clear that odds in exposed and odds in unexposed, same like as what we see it is being for the previously for the relative risk. You may understand that for the exposed it is A plus B over here, and for the unexposed is C plus D. So if you talk about the formula, it is like A divided by B divided by C divided by D is equal to AD divided by BC. Okay, let me get you through the formula as an example. So in case control study on vitamin D deficiency and osteoporosis, you may understand the case controls in exposed is 60 divided by 40 and cases divided by control in unexposed is 30 divided by 70. So the odds ratio will be 60 multiplied by 70 divided by 40 multiplied by 30. So it will be like 3.5. So the interpretation comes as odds of osteoporosis are 3.5 times higher in exposed group. If the OR is equal to 1, there is no association. If the RR is above 1, high odds of disease. If it is below, then it is lower odds of disease. Okay. When we have to take the disease, it is rare actually to say OR is equal to RR. Now we will come with the hazards ratio HR. The hazards ratio of the event is the exposed group to the hazard in the unexposed group. So you can say it used in time to event analysis, that is survival analysis. And hazards ratio as in formula is hazard in exposed group divided by hazards in unexposed group. For example, in a study of Mediterranean diet and all cause mortality, the HR is equal to 0.70. So at the time we can understand the risk of the death in the exposed group is 30 times lower than in the unexposed group. Okay, so the association is again the same. No association if the HR is 1. There is higher hazard, that is worsen outcome if it is above 1, and it is lower, actually you can say lower hazards for this. Okay. What is the risk difference versus attributed risk? The risk difference is an absolute difference in the risk of an outcome between an exposed group and an unexposed group. Again, the formula over here is that the risk exposed minus risk is equal to incidence minus incidence unexposed. So exposed versus unexposed is very important over here. Example, a drug A reduces heart attack risk in a clinical trial. So risk with placebo is 2.5, risk with drug particularly as a component used is 1%. So absolute risk reduction is 1.5. Then you can take attributable risk. Attributable risk is to state that it is excess risk of disease attributable to an exposure itself, often presented as a proportion to the total risk in the exposed group. Here you may understand that the absolute risk in percentage is like risk exposed minus risk unexposed multiplied by 100 divided by risk exposed. So you may see as an example lung cancer and smoking. There is an association and attributable risk. You may see lung cancer rates in smoker versus lung cancer rate in non-smoker. So it is very evitable to understand that how attributable risk is clearly stated over here. Then comes numbers need to treat or harm, where you can say the numbers of patients required for a given treatment to prevent, that is NNT, or a cause, that is NNH, one additional adverse event. So NNT is equal to 1 divided by RD, or NNH is 1 divided by RD. So you can say NNT, that is a treatment preventable strokes, and NNH is specific food causes allergy. So this is very important to relatively give you the clinical utility. In the example for attributable risk, it was for lung cancer and its association, smoking. And in the first case, how drug A reduced heart risk in clinical trials where placebo and a particular drug was being seen with a risk difference actually over there. Population attributable factor, that is PAF. What is PAF? The proportion of total cases of disease a population that can be attributed to a specific exposure, and thus theoretically preventable if the disease exposure was removed. So if we talk about a total population burden, and out of that there is a disease cases which is being highlighted over here, and you can say the cases attributable to the exposure, where you can say they might be nutrition deficient, and then you have to take the total population burden. So what can be the PAF? The PAF will be fraction prevent if the risk removed. If this fraction is removed, you may say that the risk is being removed. So the PAF component is very visible over here for the fraction part. So the fraction is being stated whether certain cases are attributable to the exposure. Then the PAF key definition and variables. So the key part actually to understand over here is that the exposure prevalence. So percentage of the total population exposed to the risk factor, for example specific deficiency or ultra processed food. So you can understand that the risk is very important to be stated over here for a group of a population, and it comes in the demographics that you can be stated over here. The risk of developing disease in the exposed group compared to the unexposed group. So it's like a baseline risk, and the assumption might be causal effect and no bias. The formula for PAF is like, you can say excess cases divided by the total cases. The application of PAF is being in public health planning, stunting, maternal deficient, and so a lot of things to understand the nutritional epidemiological benefits. The prevalence of the processes and the risk to stunting, exposure to a factor, for example nutrition food diet, is something you can say the application of the PAF being seen as. Interpretation in nutritional context, if you have to take the attenuated estimates and correlation, the challenge that is the measurement error, and the methodological correction that is objective biomarkers, example recovery versus concentration, to calibrate and de-attenuate the estimates. The isocaloric reliability and substitution, if you say the contextualizing the association where the balance scales compare the diet grounded 2 diet groups and the bailed 2 diet groups. So you can say the total energy adjustment, interpret the RR by swapping one nutrient with another while keeping total energy intake as constant. So it's very important to see that there is an interpretation which must have an comparison actually of being seen. And holism and causal inference. So moving beyond reduction, you can say nutrient interacts synergistically with complex food matrix. So whole nutrient is being studied. What is a triangulation of evidence? Meta-analysis, cohort studies and ecological case controls. So the interpreting a standard way of taking this as you can say a single study with context of biological plausibility, consistency across the study designs and dose response gradients, which is being seen to state that how it has a strong nutritional context. So in the summary for this chapter, I may say that the measures of association and effects in nutritional epidemiology quantify the relationship between the dietary exposure and the health outcomes. So it is very important to understand the association, where we have also understood the risk, rates and odds, which describes the disease occurrence, while relative risk, odds ratio and hazard ratio compare the risk between the groups. So comparison is there on the other part, while versus the disease occurrence on the first part. Absolute measures like risk difference and attributable risk also show the actual impact of exposure. So you can understand like how it is being important to understand the absolute measures. Okay, the population attributable fraction, that is PAF, estimated the proportion of disease in a population that could be prevented by eliminating the risk factor. If you eliminate the risk factor, you can see the proportion of the disease in that population can be prevented. So PAF is also very important for preventive part of estimation. Interpretation requires a careful consideration of confounding, measurement errors and dietary complexity versus whole diet to a complex diet to a single component. So interpretation takes a major role in, and interpretation should be done very carefully. So these measures are essential for informing public health interventions and nutrition policy. So with this, we can take an end to this chapter and a discussion where you can find these references very important to take this and understand the PAF and even the ratios over here. So with this, I end for this. Thank you very much.